Hi guys, I'm Mary and PANCHO. My topic for today is static memory allocation. Memory allocation. Memory allocation is a process by which computer programs and services are assigned with physical or virtual memory space. The memory allocation is done either before or at the time of program execution. There are two types of memory allocation. First is compile time or static memory allocation, runtime or dynamic memory allocation. Static memory allocation. Static memory is allocated for declares variables by the compiler. The address can be found using the address of operator and can be assigned to a pointer. The memory is allocated during compile time. Advantage: simplicity of usage, efficient execution time, need not to worry about memory allocation, reallocation, freeing of memory. Disadvantage: main disadvantage is wastage of memory. Memory can't be freed when it is no longer needed. Key features: variables get allocated permanently. Allocation is done before program execution. Less efficient, there is no memory reusability. Dynamic memory allocation. Memory allocation done at the time of execution or runtime is known as dynamic memory allocation. Function calloc and malloc support allocating dynamic memory. In the dynamic allocation of memory space is allocated by using this function when the value is returned by functions and assigned to pointer variables. There are two cases when this type of allocation is performed. First is allocation of the process is known as compile time. The compiler generates an absolute code for the process, and if the allocation of the process needs to be changed on memory code must be compiled. Second, location of the process is unknown at compile time. The compiler generates relocatable code instead of actual memory address. Address in this case are relative to some known point. With this, it is easy to load the process to a changed location and recompilation is not needed. In both the case, size should be known before start of the execution of the process.
Segmentation. What is segmentation in operating system? In operating systems, segmentation is a memory management technique in which the memory is divided into the variable size parts. Each part is known as segment, which can be allocated to a process. The details about each segment are stored in a table called segment table. Segmentation is a technique for breaking memory up into logical pieces. Each piece is a group of related information, data segments for each process, code segments for each process, data segments for the operating system. Like paging, used for virtual address and use this to make a memory look bigger than it really is. Segmentation can be implemented with or without paging. Segmentation is also a process divided into segments. The chunks that a program is divided into which are not necessarily all of the same sizes are called segments. Segmentation gives users view of the process which paging does not give. Segment table. Base address. It contains the starting physical address where the segments reside in memory. Limit. It specifies the length of the segment. Translation of two-dimensional logical address to one-dimensional physical address. So, address generated by the CPU is divided into segment number S, number of bits required to represent the segment, segment offset D, number of bits required to represent the size of the segment. There are two types of segmentation. Virtual memory segmentation. Each process is divided into a number of segments, not all of which are residents at any one point on time. Simple segmentation. Each process is divided into a number of segments, all of which are loaded into memory at runtime, though not necessarily contiguously. Advantage and disadvantage of segmentation. Advantages: no internal fragmentation. Segment table consumes less space in comparison to page table in paging. Disadvantages: as processes are loaded and removed from the memory, the free memory space is broken into little pieces, causing external fragmentation. Segmentation issues. Entire segment is either in memory on disk. Variable size segments leads to external fragmentation in memory. Must find the space big enough to place segment into. May need to swap out segments to bring a new segment in. Segmentation with paging. Most architectures support segmentation and paging. Basic ideas. Segments exist in virtual address space. Base address in segment descriptor table is a virtual address. Use paging mechanism translate this virtual address into a physical address. Now, an entire segment does not have to be in memory at one time. Only the part of the segment that we need will be in memory. Memory segmentation. Memory segmentation describes the system of segmentation processes and loading in the information into non-contiguous spaces in memory. This allows for better efficiency in memory management. Through the system incurs external fragmentation, it allows for smaller chunks of segmented processes to be loaded. A program is basically a collection of segments, and the segment is logical units such as main program, procedure, function, method, object, local variable, and global variables, symbol table, common block, stack arrays. Characteristics of segmentation. Segmentation is a partitioning scheme is variable size. Partitions of the secondary memory are commonly known as segments. Partition size mainly depends upon the length of modules. Thus, with the help of the technique, secondary memory and main memory are delivered into unequal size partitions. Segmentation is another way of dividing the addressable memory. It is another scheme of memory management and generally supports the user view of memory. The logical address space is basically the collection of segments. Each segment has name and a length. Basically, is a process divided in two segments like paging. Segmentation divides or segments the memory. But there is a difference, and that is while the paging divides the memory into a fixed size, and on the other hand, segmentation divides the memory into variable segments. These are the loaded into logical memory space. Need of segmentation. One of the important drawbacks of memory management in the operating system is the separation of the user's view of memory and the actual physical memory, and paging is a technique that provides the separation of these two memories. User's view is basically mapped onto physical storage, and this mapping allows differentiate between physical and logical memory.
File system operation. File system operations. By considering the fundamental operation we can carry out using file system, we can see the inherent issues associated with their implementation. A file system typically manages operations such as storage management, file naming, directories, folders, metadata access, rules, and privilege. A file open operation typically requires looking up a file path in the file system. A file is a collection or related information that is recorded on secondary storage, or file is a collection of logical related entities from users perspective, a file is the smallest allotment of logical secondary storage. Most programs will perform the following kinds of function. Create new files, open or start using a file that was created prior to the running of this program. Increase the size of the file, extend if and when the file is exhausted the current allocated space. Stop using close the file after the program has finished using it. Delete a file that already exists. Block data transfer operation transfer data from read or to write the device designated by the program. Basic file system operation. Initialization, we must be able to turn a newly allocated region of a disk into a file system or part of a file system. In any file system, there must be at least one fixed location structure. In more traditional Unix file system, there are many fixed location structure. Mounting. Mounting is the act of making physically file system representation on some medium available for use by the operating system and programs it may run. To do this, we must read the file system metadata from the medium. Unmounting, the primary task achieved by unmounting is to flash the cache metadata so that the representation on disk will be consistent and to mark the system as being clean. Once it is marked clean, the file system representation should only be accessed after a succeeding mount. Creating files. To create a file on a Unix system, you need the following information: the directory that will contain the file, the name of the file within that directory, all the metadata values to be stored in the file, inode, the name to inode mapping will be inserted into the specific directory. The data blocks of the file can be created at any time once the inode has been allocated. Creating directories. All activities required to create a file must be carried out then creating a directory, but in addition, the directory data blocks must be initialized to represent an empty directory. Opening files. A file open operation typically requires looking up a file path. In the file system, this involves two parts: finding the directory containing the file either from the root directory or from some other node directory, and finding the files inode within that directory. Writing to files. A file system write involves a process identifying the file to be written, usually by giving its handle, data to be written to the file, and the location in which that data is to be written. Advantage. Efficiency. A file can be located more quickly. Naming. It becomes convenient for users as two users can have same name for different files or have different name for same file. Grouping. Logical grouping of a files can be done by properties, all Java programs, all games. Disadvantage. External fragmentation will occur, making it difficult to find contiguous blocks of space of sufficient length. Compaction algorithm will be necessary to free up additional space on disk. Also, with free allocation, it is necessary to declare the size of file at the time of creation.
Hi, I am Angelika Khyle TACCAD. My report is all about file system data structures. Structures. A file system is a data structure for storing and retrieving data block as an archive and collection of files. A file system, in other words, divides data blocks into files, directories, and file information. The data is easily isolated and identified by separating it into pieces and giving each one a name. Another is a file system is also known as a file system. It is a mechanism and data structure used by operating system to regulate how data is saved and accessed in the computer. The history. A file system is the data structure designed to support the abstraction of data blocks as an archive and collection of files. In other words, a file system organizes the data blocks into files, directories, and file information, while previously referring to the physical, paper files, and term file system was used to refer to digital files as early as 1961. By 1964, it had entered general use to refer to computerized file system version. The file system structure is the most basic level of organization in an operating system. Providing a common file system structures ensure users and program are able to access and write files. File system break files down into two logical categories, shareable versus unshareable. There are three types of file structure in OS, a text file, an object file, and a source file. Text file is a series of characteristics that is organized in line. While object file, it is a series of bytes that is organized into blocks. And the last one is the source file. It is a series of functions and processes. Features in security. There are the volume management, support for page and direct input-output, high capacity, fast file system recovery, metadata storage, vNode interface, shared file system support. Features in network. A file system is a process that manages how and where the data on the storage disk. Typically, a hard disk drive is stored, accessed, and managed. It is a logical disk component that manages a disk's internal operations as it is related to a computer and it is abstract to human user. Features in file system. There are the space management, file names, directories, metadata, file system as an abstract user interface, utilities, restricting and permitting access, maintaining, and integrity. The advantage of data structures is since the file-based system is used by smaller organization or individual user, it stores comparatively lesser amount of data. Hence, the data can be accessed faster and more easy. Also, it is possible to take faster and automatic backup of database stored in file of computer-based system. Another advantage is compactness, data retrieval, editing, remote access, and sharing. The disadvantage of data structure is slow access time, presence of redundant data, inconsistent data, data integrity problem, difficult in recovery of corrupt data, lack of atomicity, problem in concurrent access. Hardware specification. File system workflow. The hard drive, the partition into a file system, to directory and into file. What are they do? Hard drive is the hard drive component that stores all of your digital content, your documents, pictures, music, videos, program, applications, and operating system represent digital content stored on hard drive. And the partition, it is a logical division of hard drives that is treated as separate unit by operating system. This allows the drive to operate as several smaller sections to improve efficiency. Although it reduces usable space on the hard disk because of the additional overhead from multiple OS. The file system, it is the method and data structure that the operating system used to control how data is stored and retrieved. File system also can be used on numerous different types of storage that use different kind of media. And directories, it is the special type of file that contain a list of its files and subdirectories. It also contain metadata about directory, such as who can access it in attributes. How to install? First one is open the server manager and click manage, add roles, and add feature wizard. Second one is the add roles and the feature wizards open. Third, click server role and select file and storage services. Expand file and ICSI services. Fifth is the select file server and server from NFS. The last one is click add feature to include selected NFS feature. In this NTFS, there are four: the disk compression, file encryption, file folder level security, and disk code. Disk compression is the file to create more storage space. File encryption, it is the allows you to transparently encrypt file data. And the file folder level security, it allows you to control access to file and folders. Disk codes, it is allows you to control disk usage on the per user basis. Thank you.